The final aspect of Pythagoras theorem, or application of Pythagoras theorem, we're going to be looking at is how to apply it to 3D problems. So let's have a look at the 15, 16, and 17. A 50-meter rope is attached inside an empty cylindrical wheat silo of diameter 12 centimeters as shown. How high is the silo? Okay, well, we want the height. Let's do h for height. And we see that they've already labeled it for us, so this one's pretty straightforward. So let's use Pythagoras theorem. Well, let's just go straight to h because we've done enough times. Okay, so this is one of the shortest sides, so we have to start with the hypotenuse. So 50 squared take 12 squared. And this one we will work out is approximately, so root 50 squared minus 12 squared, square root 50 squared minus 12 squared is approximately 48.5 if we round to 3/6 fix. 48.5 meters. So nice easy one to start us off there. Okay, let's do example 16. A room is 6 meters by 4 meters and a height of 3 meters. Alright, so we've got a rectangular prism here. Find the distance from a corner point on the floor to the opposite corner point on the ceiling. Okay, so 3D gets a bit more tricky to draw, but actually, I'll do my best to draw this room. I'm half decent at drawing rectangular prisms, so let's see how we go. Something like this. Alright, keep in mind that this is 3D and all the corners meet at right angles. Or let's assume that this is a rectangular prism. Okay, so we're going to go with that assumption. A room is 6 meters by 4 meters with a height of 3 meters. It probably should have said something to do with, this is going to be a rectangular prism, but let's assume that. Otherwise, it would be. We'd have to use other methods, right? So let's go from here. Alright, so to the opposite corner on the ceiling, so like here. Okay, so picture this 3D. It's probably one of the trickiest parts about 3D, just trying to imagine it. But hopefully it's not too bad. So it's not a perfect line, but that's the line we want to find. Distance, D for distance. Okay, so how do we do that? Well, a very common strategy is to find this distance first. On the floor, so the diagonal of the rectangle on the floor, because we know that the floor between 6 and 4 there, that's a right angle. So let's say, I don't know, let's just call this blue line distance x. So we're going to have to use Pythagoras theorem twice, because then, here, there's a right angle there as well. So that's how we're going to find D. So x equals root 4 squared plus 6 squared equals 16 plus 36 is 52. Now, since we know that we're going to use Pythagoras theorem again, let's just leave this as an exact value, and now let's find the value of D. So D is the hypotenuse again, so it's going to be x squared plus 3 squared. Now, since we know x is root 52, x squared must be just 52 plus 9, which is approximately how much? Let's calculate that. Square root 52 plus 9 is 61, 7.81 length is meters. So you'll find that in a lot of problem solving questions, you may have to apply Pythagoras theorem more than once So always keep that in the back of your mind. The last example of this chapter, hooray! Here we go. Pyramid of height 40 meters has a square base with edges of 50 meters. Determine the length of the slant edges. Alright, so let's draw this thing. Okay, to draw a pyramid, I like to, since it's 3D, this is how I draw a pyramid. I do like a square, but like that, but this is a square, by the way. And then I kind of, maybe I make it even more angled, like a rhombus. And then let's say here's the tip of my pyramid. Alright, here's my center of my pyramid. Maybe I just do a dotted line to represent the center of my base to my tip. Come on, draw better straight lines, Mr. Chen. And something like this is our pyramid, and these will all be right angles. Okay, so I'm going to label that. You can probably do a better drawing than me, but here's mine. Okay, it's got a height 40 meters, so this dotted line here is 40 meters long, and the width square base is 50 meters. Alright, I'm going to put, since it's a square, we're going to do that. This makes this question a lot easier, so because if it wasn't a square base, then it just gets a lot more tedious. And it wants the length of the slant edges. Now, the fact that this is a square base, that means the slant edges are all going to be the same length. So let's just pick one and color it green. That's the slant edge. Alright, let's just call it, I don't know, let's just call it X. Okay, so how can we find X? Well, the first thing we need to do is, let's see, what's the quickest way of going about it? Alright, we actually need to, I'll draw it in the blue line, recognize that if we draw a line from the base of the square to one of the corners that connects with the slant height here, we're going to make a right angle. Because this is 3D, it doesn't look like it that I've drawn it, but just imagine this in your head, right? So that's actually a right angle there. So we're going to have to find the distance of the blue line. So you can do this a number of ways. You can find the length of the whole, imagine the blue line goes all the way like that. You can find the whole diagonal and halve it, or for now we might just draw another dotted line here. Here's another right angled triangle. Alright, let's call this blue line, I don't know, D this time. So since we know that all the edges of the square base are 50 centimeters, then this is 25. This side of this triangle is 25 centimeters, and so is that side of the base triangle, this little one that we're trying to use. Okay, so a bit tricky. Diagrams help a lot. So if I try to find that distance first, distance is going to be, it's the hypotenuse, so 25 squared plus 25 squared, which is square root of, what's 25 squared? That is 625 plus 625 is, or use a calculator, 1250. Now, since we know that we need to use Pythagoras theorem again, we're just going to leave that exact value, because now we can find X. So X is now going to be square root of, again, that's the hypotenuse, so it's going to be D squared plus 40 squared, because now we need to use that height, which equals square root of, so D squared will be 1250, plus 40 squared is 1600, equals, well, let's just type this into the calculator again, square root 2850, Let's do that. Square root, square root 2850, 53.4 if we do 3 stick figures. 4, and it's a length, so meters. It's a pretty big pyramid. Okay, so always try to draw diagrams when it comes to these types of this type of problem solving, and ask yourself, okay, where are my right angle triangles? Where can I apply Pythagoras' theorem, and go from there.